So now we are going to discuss about oxygen. See how the oxygen is prepared. Preparations, chemical properties only important. That preparations. See the oxygen related compounds. So all you can take. So that means where it is easily coming outside. So means metal, largest size of metal and smallest oxygen. So that is unstable, easily donated oxygen. So Cu2O. So mercury oxide, all D black elements. So combination MnO2. So just you heat oxygenated compounds. So that is KMnO4, K2Cr2O7, NaNO3. So oxygenated compounds you are heated. So that is KClO3, KClO4. So just all compounds just you heat. So oxygen is easily coming outside. Next, otherwise you take hydrogen peroxide. Hydrogen peroxide also you can heat. 2 moles of H2O plus water. Next, otherwise you take in acidic medium. So KMnO4, KMnO4 acidic medium. So it treated with H2SO4, oxygen is coming. So that is acidic medium, it become as what? MnSO4. So plus 7 become as plus 2. So next K2SO4. Next oxygen is eliminated. Next, not only this, K2Cr2O7 treated with H2SO4, then also the oxygen is generated. So potassium sulfate, next chromium sulfate are the products. So like that. So these two are famous in your D black elements also. So that is the preparations mainly. Next, you take chemical properties. See, in chemical properties, the oxygen is a highly reactive substance. So that's why it is readily react with metals also. React with metals, react with non-metals. Next, react with compounds also. So react with compounds. Next, in the organic chemistry means combustion. CXHY. So this. See, react with sodium. So you are getting Na2, magnesium. So MgO, aluminium, Al2O3, silicon. So SiO2. So that is metals, any first, second, any D black. Suppose D black elements you are taking FeO, Fe2O3, Fe3O4. So copper with oxygen. So like that any metal. Next, non-metals. Non-metals react with oxygen. So that means carbon react with oxygen. CO2. Sulfur, SO2, SO3. So nitrogen, NO, NO2. So like that. So any non-metals, they are readily reacted with that. Next, phosphorus, suppose P4 react with oxygen. You are getting a P2O3 and P2O5. Suppose chlorine reacted with oxygen. So Cl2O, Cl2O3, Cl2O5, Cl2O7, like that. So oxygen is readily reactive with every element also. Next, reaction with compounds. So reaction with compounds means so oxygen react with NO. You are getting NO2. Next, oxygen react with SO2. You are getting SO3. So this is where we are using in contact process. So platinum or nickel. That next oxygen react with ammonia. You are getting NO. So preparation of HNO3. So Oswald's process. Next, so anything zinc sulfide react with oxygen. So you are getting ZnSO4 also possible depending on temperature. So zinc oxide plus SO2. So this is extraction of the metal. We can use that one. Next, CXHY. It is reactive with oxygen. So it is become as a carbon dioxide. Hydrogen means H2O. How much carbon dioxide? X moles. So how much oxygen? X moles require. Next, so it is H2O. You are getting Y by. So Y by 2 H2O is possible. So here one oxygen, here two oxygen. So you can take Y by 4. So the hydrocarbon react with X plus Y by 4 of oxygen. So that is a combustion reaction. Next, here oxides are important in oxides. So how many types of oxides? So acidic oxides, basic oxide, amphoteric oxides. Next, neutral. So neutral oxides. Next, the mixed oxides. So many types are there. Mixed oxide. Next, peroxides. Next, superoxides. Next, suboxides. So like that. So the oxygen is reactive with so many all types of compounds only in that important. Acidic oxides. What are acidic oxides? Non-metal. Non-metal oxides. Non-metal oxides are acidic oxides. So CO2, SO2, SO3. So P2O3, P2O5. So nitrogen, N2O3, N2O4, N2O5. Next, so nitrogen, phosphorus, sulfur also completed. Next, Cl2O, Cl2O3, Cl2O5, Cl2O7. So all are coming under non-metallic oxides. So basic oxides. What are basic oxide means? Metal oxides. So Na2O, CaO, BaO. So that all are first group and second group elements are famous basic oxides. Amphoteric. Amphoteric means both acidic and basic. So Al2O3. So close SiO2 also little bit. Next, zinc oxide. Yes, that are coming. Neutral. Neutral means carbon monoxide. So N2O. So NO. So that all are coming neutral. So they are not reactive with acid and base. Amphoteric means both reacted. So mixed. So mixed oxides you are getting Pb3O4. Fe3O4. So here lead plus 2 will be there, plus 4 is there. Iron plus 2 is there, plus 3 is there. So like, so you take Mn3, manganese also. You can get. So peroxides. So who are forming peroxides? So first A group. First A and second A. These are forming. First A group is forming peroxide MO2. Next, MO2 is superoxide. So actually peroxide means what? So peroxide is O2 minus 2. So that's why M2O2. M2O2 is the first A group, peroxide. Next, second group peroxide is M plus 2. So that means MO2. That is. Next, superoxide. Superoxide is forming only first A group elements only. So what is superoxide? O2 minus 1. So MO2. See, first group MO2 is superoxide. Second group MO2 is peroxide. Next, suboxide. Suboxide means oxygen is less. Oxygen amount is less compared to the beside compound. So that is C3O2. So one famous example, that is suboxide. Suppose you take N2O. So N2O also. So nitrogen, 2 nitrogen, it will be there. So that is N2O, Pb2O. So some compounds. So compared to lead wants PbO2. So one lead only, two oxygens or one oxygen required. But here two leads are taking one. So that is the less amount of oxygen available. That is called as suboxide. Next, so we are discussing about ozone, O3. That ozone preparation. So actually this is prepared in silent electric discharge. Discharge tube. So that is oxygen is sending in silent electric discharge, you are getting 2 moles of ozone. So famous is Siemens ozonizer. Siemens and Broadis ozonizers. So in these two process we are preparing the ozone. Next, if oxygen touches the UV light, so then also it becomes as O3, ozone. So that's why that UV light is protected from the that unwanted. Next, so electrolysis process also you will get, that is not that much more. Next, you take chemical properties. So chemical properties of ozone. See here, this is what acting as oxidizing agent. So famous is oxidizing agent, it supplies. Next, in the organic chemistry, ozonolysis. So pi bonded system. So pi bonded system also easily reacted with ozone. See some equations we see in oxidizing. So oxidation means if the compound oxidation state is increases, then that is useful. So in oxidizing, suppose you are taken HCl. So HCl minus 1, it becomes as Cl2 0. So oxidation state is increases. Suppose Fe plus 2. Fe plus 2 become as Fe plus 3. Suppose the ferrous sulfate you are taken means ferric sulfate, Ki. So that become as I2 with that oxidizing nature. Next, suppose PBS, lead sulfide. Suppose you are getting PbSO4. So zinc sulfate. Zinc sulfide also become as zinc sulfate. So NaNO2, sodium nitrite. It become as sodium nitrate. Next, Na2SO3, sodium sulfite. So that become as Na2SO4. Oxygen is supply. See, K4, FeCN taken 6. So this is what? Plus 2 oxidation state. You are treated means K3, FeCN taken 6. So oxidation state plus 2 to plus 3 increases. Suppose you take H2S, S minus 2, it becomes as sulfur. So otherwise, you take S otherwise SO2 and SO3 depending on the concentration of ozone what you are taken. That. Suppose the silver you are going to treat it. So silver oxide. So that is very. Next one famous is tailing of mercury. So tailing of mercury. Suppose mercury is reactive with ozone. You are getting H2O. So it is looking like a tail structure. So it has a tail structures. It is inside the test tube. So that's why it is called as a tailing of mercury. Next, pi bonded system. Pi bonded system we called as ozonolysis. So CH2 double bond CH2 treated with ozone, zinc plus water in the presence of zinc. So direct you break the two bonds, both sides you add oxygen and oxygen. So formaldehyde 2 moles. Suppose you treated with only ozone and water. So here water, one oxygen, hydrogen peroxide is happened. So that's why that formaldehyde become as a formic acid. So that is. So HCOOH. So you are getting formic acid. So in ozonolysis process, zinc is there means aldehydes are ketones. Zinc is not there means the aldehydes are converted into acids. So that is important here. Next compound we are going to discuss about water. So H2O. So the preparation is not that much of that hydrogen and oxygen. So in electrolysis, high electric point, you are getting 2H2O. That general. Next here, this is universal solvent. So it is universal solvent, high dielectric constant. It has a high dielectric constant, means polar nature will be there in this. So chemical properties only more and more. See water. See water is reactive with metals. React with metals, then what happens? You are getting basic. Next, these are reactive with non-metals. Non-metals means you are getting oxo acids. Next, not only that, water is added means you called as a hydrolysis. Right. Next, so hydrates, carbides, nitrides. So everyone is reactive with phosphides. So also react with the water. Next, salts hydrated. So salts are hydrated. So they are a combination of water molecules. They are available. Next, suppose the D block element compounds. So D block element compounds means they are forming complexes. Suppose we see the examples of one by one. See, sodium react with water. You are getting water. NaOH plus hydrogen gas. So magnesium, water, you are heated. So MgOH taken twice. Hydrogen gas coming outside. Next, non-metals. F2 react with water. So 2HF, 2 moles means 4HF plus O2. Next, suppose 3 moles you take. 3 moles means 6HF plus ozone. Suppose chlorine react with water. So you are getting HCl, HClO, hypochlorous acid. So that is a non-metals. Suppose it is a carbon react with water, vapor. So carbon monoxide plus hydrogen. So you are getting water gas. So water gas or syngas, you call this. Next, metal oxides. So metal oxides react with water. You are getting NaOH. Next, MgO react with water. You are getting MgOH taken twice. So you are getting that bases. Suppose non-metal oxides. Non-metal oxides are reacted. So non-metal oxides react with water. You are getting oxo acid. So CO2 plus water. You are getting H2CO3, carbonic acid. Next, P2O3 plus water, phosphorus acid. P2O5 plus water, phosphoric acid. Next, N2O3 plus water, HNO2, 2 moles. N2O5 plus water, 2 moles of HNO3, nitric acid. Next, SO2 react with water. So sulfurous acid, SO3 plus water. You are getting that. Sulfuric acid. Next, hydrides. Hydrides are reacted. Suppose calcium hydride. So react with water. So 2 moles. You are getting water. Calcium hydroxide plus hydrogen gas is coming outside. Suppose calcium phosphide. So Ca3P2 treated with water. So calcium hydroxide common, phosphorus and hydrogen. You are getting a pH3. So magnesium nitride, Mg3N2 treated with water. So MgOH taken twice a common, nitrogen and hydrogen. So NH3. Suppose carbide, CaC2 treated with water. So here hydroxide is going outside. So C2H2. So that we are getting compounds. Next, hydrolysis. So hydrolysis means the compound is reactive with water. So ester hydrolysis. So CH3 COOET plus water. So acidic medium or basic medium. So CH3COOH plus ETOH, ethyl alcohol. So bismuth chloride react with H2. So you are getting a BiOCl plus 2HCl. Suppose next any other compound, suppose ammonium carbamate also you can take. Otherwise the compounds means PCl3, PCl5, PCl3 plus water. Next PCl5 plus water. So here PCl3 with water means H3PO3 plus HCl is going outside. Here POCl3 plus HCl will be eliminated. Next, suppose the salts are suppose the CuSO4. So it is in white color. It is react absorbs 5 water molecules. CuSO4 5H2O. It is absorbed in blue color. So crystallines they are forming in hydrate form. So gypsum, that is what CaSO4 absorbs 2 water molecules, that is gypsum. Suppose CaSO4 half H2O, it is what plaster of Paris. Suppose magnesium MgSO4 7H2O. Next same barium, so BaSO4 2H2O. So one point you remember, so in salt, smallest size absorbing more water molecule, large size absorbing less amount of water molecule. So that is hydrated form also it can form. Next compound hydrogen peroxide. So that preparations. So there is salts only. So Na2O2, sodium peroxide, so barium peroxides, so any peroxide, so that is treated with water, otherwise H2SO4 or any H3PO4. So here H plus O2 minus 2, direct you are getting a H2O2, hydrogen peroxide. Next, some in a logical manner also, that is a barium peroxide BaO2 react with CO2 plus so H2O in the presence of water. What happens? BaCO3 H2O2. You are getting. Next, that is anthraquinone. So that is a famous anthraquinol easily forming. OH and OH. It is heated in the presence of air. So then it is oxidizing agent means it is become as anthraquinone. So double bond O plus here 2 hydrogens eliminated. You are getting H2O2. Next famous is H2SO4 electrolysis process. So H2SO4 we are sending electricity electrolysis, it become as HSO4 minus. Next 2 moles it is combining, you are getting H2S2O7, that oleum, that H2S2O8 is possible. Next further we are treated with water. So 2 moles of H2SO4 plus hydrogen peroxide is possible. So the electrolysis of H2SO4 also you are getting the H2. Next Hydrogen peroxide chemical properties. It is mainly two important points. One is oxidizing agent. It is acting as a oxidizing agent as well as a reducing agent. Because of oxygen supplying means oxidizing. Hydrogen supplying means that is a reducing agent. So oxidizing agent means oxidation state will be increases. So in what way it is H2O2 become as H2O plus nascent oxygen. This is the responsible for oxidizing. So what are that? So PBS, it become as PbSO4. So oxygen is supplying for that. Suppose you take NaNO2, it become as NaNO3. Oxygen is supplying. Next, suppose Ki, I minus, that become as I2. So that means 0. Oxidation state is increases. Suppose you take H2S, that is become as a sulfur. So minus 2 become as 0, increases. So ferrous sulfate. So Fe plus 2. So that become as Fe plus 3. So ferric sulfate. Suppose you take aldehyde. So formaldehyde. So that become as a formic acid. So means supplying oxygens only. Suppose benzene. Benzene we are heated with H2O2. You are getting a phenol. So oxygen is supplying that one. Next, we see the reducing. Reducing means reverse. So removal of oxygen. So whatever we discussed previous, that oxidizing, so exact opposite you can take. That is what reducing character. Suppose the silver oxide. So silver oxide, generally it is unstable. Suppose we are treated with H2O2. So that become as silver only. That is. Next O3 become as O2. Next. Suppose MnO2. MnO2 in the presence of H2SO4. It is what? Plus 4. Become as plus 2. So that is MnSO4. Suppose PbO2 become as PbO. So, otherwise, how it is acting means H2O2 is absorbing one O, become as H2O plus O2. This is the reducing nature. So oxygens are taken by H2O2, they are become as releasing that one. Next, you take Fe plus 3. So either complex or whatever it may be. Fe plus 3 become as Fe plus 2. That is. So NaOCl treated means you are getting NaCl. So oxygen is eliminated. So KiO4 you are heated. So you are getting a KiO3. So like that. Next in oxidation only one important is there in oxidation. In oxidation what is that? K2Cr2O7 in acidic medium. H2SO4 with hydrogen peroxide. So it is important. You are getting a CrO5. So it has this is very important chromium, double bond O and O. So it has a butterfly structure. So one important hydrogen peroxide K2Cr2O7 in acidic medium. That next in organic also one alkene. Alkene react with hydrogen peroxide. So you are getting a cyclic ether. Next, that is treated with water. So you are getting glycol, ethylene glycol is possible. Next one famous reaction. So hydroboration and oxidation, HBO also important, HBO reaction. So that is CH2 double bond CH2 hydroboration. So diborane we are treated. So you are getting CH3 CH2 BH2. Now this is a react with water and hydrogen peroxide. So what will be the products? So here plus minus, here carbon is minus, this is a plus. So carbon minus react with H plus, your answer is alkane with hydrolysis. Suppose you are taken hydrogen peroxide, so both sides CH3 CH2OH. So in hydroboration you are added with water, your answer is alkane. If hydroboration is added with hydrogen peroxide, you are getting alcohol.